Bismillah. Today we're going to talk about the first moment of area. Why do we need it as engineers and what's its application, right? Before talking about it, let's give a quick introduction. Actually, the first centroid of an object or of an area, or what we call the center of a gravity, is exactly or similar really to the first moment of area as a concept. For example, if we have a triangle here, usually this force, which is W1, is applied in its center of a gravity or its centroid. Same for this rectangle and same for this triangle. But if we want to convert all of these forces into single equivalent force with its centroid, but this centroid is for the whole object, this is what we call first moment of area. Why do we need it? We're going to talk about that later. I mean, why do we do that at the end of this session or maybe in the later series? Right, so what's the moment of area? What's its definition? It is used to locate the summation, or used to locate, sorry, the centroid or the center of any shape, which is this shape. Of course, we talk about regular shapes. So if we have something like that is something different, then we'll do something else. I mean, we'll talk about it later. So the first moment of area, which is x bar, which is this one here, is actually what? Is actually the summation of the areas multiplied by, which is this area plus this area plus this area, multiplied by the distance of, let's call it x, distance centroid, that is from the centroid, divided by the full area of the whole object. Same for the y bar. We called y bar, so it is y bar multiplied by a divided by summation of a. We'll see it in examples. This is a quick interview in order to understand what do we mean by moment of area, first moment of area. And this is another example, or actually it's the same example if we look at it in 2D here. So this point C is the equivalent or centroid of the whole project or of the whole object. Okay, looking at the next, let's see the next slides. Now, engineers brought to us some regular shapes here. So quickly to find the centroid of an object. So for example, if you have a triangle, so x bar, there's no x bar actually. We only have y bar, which is h over 3. And the area is bh over 2. If we have a semicircle, that's the y bar, that's the x bar, and so on. Right? Semicircular arc. It's the same here. I mean, these are guidelines given by engineers in order to do it quickly. Let's look at an example that we need to solve in order to do it. If we have this shape, for example, and we are asked to find the first moment of area, determine the centroid of this object. So where is it? Is it somewhere here, somewhere here? We don't know. So the first step is to break this into a different, into pieces, let's say. So this is the first one that's here. This is a rectangle. This is another triangle, right? We have a circle that we need to subtract because we don't really have a circle, right? And we have this arc over here. And actually, starting with the first moment of area calculation, we need to take an axis. So let's take our origin axis is this axis, which is the x here. So anything above x will be positive, anything beyond or below x will be negative, right? So let's start quickly to understand. Let's start doing it one by one. So if you have a rectangle, the area of a rectangle that we have here is 120 by 80. Okay, so because this is 120 and it's 80, so we took it from here, right? So 120 by 80 will give me the area of the rectangle. The x bar, which is this distance from here to here, will be half of the 120, which is 60. And the y bar will be 40, which is half of the 80, right? Now multiplying each one by the area. So x bar multiplied by this area will give me this number, and y bar multiplied by this area again will give me that number. So multiplication. So start doing that for every piece. For the triangle, the area is half bh, we know that, right? But we put negative because it's below the axis, as I said. So it's negative 20, right? When put it with its sign. We do that for the semicircle, which is this one, right? Also, you can use the triangles, the table, sorry, that we saw in the previous slide. And then this circle, which is not really a circle, it's just because of we added. We don't have really a circle here, right? So we subtract it. So it's minus, right? And we do the same. X bar multiplied by the area, y bar multiplied by the area. So we got what we call summation of x bar a, summation of y bar a, and this is the summation of the area. Okay. So what's the next step? The next step is to calculate what we call x bar. So if we come here, let's say x bar is summation of this x bar a. So let's write it here, summation of x bar a divided by the summation of the area, which is this number, 13.828. If you do the math, we will get 54.8 millimeter. We'll do the same for y bar, which is summation of y bar a divided by summation of area. If you do the math, you will get 36.6 millimeter. If I want to choose another color for illustration, so I'm going to show you here. So if we move from here to here, about 54.8, it's somewhere in the middle, approximate, and y bar move up by 36.6, so our centroid is somewhere here. Let's see, our centroid of the whole object. Okay, that's what we want. That's what I want to show you today. Hope you enjoyed it. But I want to just quickly say something about why do we need this as an application. Actually, usually when we have a plan and we have columns, right, there is something called, this is advanced. Of course, this is advanced, but I want to just quickly explain it. If we have an earthquake force that's applied to a story, we need to calculate the stiffness of each element and then convert or move the whole system into something that we call, in a point here, that we call center of rigidity. And to do that, we will use first moment of area, which is the one that we just saw. And why do we do that? We need to know what's the opposing force, FF, let's call it, that we need to calculate, or we need to design for taking the force of the seismic. Hope you enjoyed the video, and next video we're gonna see how to calculate the first moment of area if it is irregular shape.